Hi everyone, I'm Dr. Lisa Golebiewski, and for those of you who don't already know me, I received my PhD in molecular virology and microbiology from Baylor College of Medicine in 2011. I've also done research in a variety of fields, the most recent of which is this project I'm presenting. Silken Windhound population analysis using de-identified ISWS registry data. I wanted to do this project because we have a breed that's almost 40 years old and not a lot of quantitative data to examine. So that means that if we want to know what do pedigrees look like, what does the population look like, what silkens are being bred, what do litters look like, what's the generation interval, how does all of this compare to other dog breeds, what's our effective population size, which is really important for knowing the stability of the breed long term. What about COI and kinship? What does that look like over time in Silken Windhounds? And what about genetic diversity? We have genetic diversity projects, and it would be great to see if they are having a positive impact on the breed. But the most important question of all of these right now was, what available tools can we use to answer these questions? Because there are a lot of tools out there, and the ones that I used are Retriever and PopRep. Retriever is a Dutch program, and it functions as a population management tool. It uses a breed's registry data and evaluates relationships between individuals. Data from the registry database can be de-identified or original formats, and the only info it really needs to build these pedigrees are animal ID, sire ID, dam ID, sex, and animal's date of birth. It's capable of comparing subpopulations, so geographic subpopulations or color varieties or any other subpopulation you could think of, and you can compare them to each other or to the general population. It has a companion program pointer that can simulate breeding programs run over X years into the future based on multiple management models. And the second program is PopRep. It's a web-based program, and it again, like Retriever, uses a breed's registry and evaluates relationships between individuals. The data from the registry database can be de-identified or original formats, and again, it needs animal ID number, sire ID number, dam ID number, sex, and animal's date of birth. It automatically builds reports using latex-based templates and the output data, which is pretty handy. But why these two programs? What can they tell us? Both programs are free to use. They're currently available and maintained by universities. We can easily import our data into these programs, and by linking individuals through a pedigree with a timeline, we can look at yearly trends. So pedigree completeness, parental age, litter numbers, generation length interval. We can see how they change over time or when there's important events in our breed's history. We can also evaluate effective population size, get overall breeding numbers and trends over time, and we can evaluate the kinship coefficient between pairs of registered silkens and the coefficient of inbreeding, which is pedigree and probability based. But we should make a note that we can't compare kinship coefficient or coefficient of inbreeding well between founders because their pedigrees are incomplete. And now that I've explained all the great stuff about Retriever and PopRep, there are limitations, the biggest of which is that if we put garbage data in, we're going to get garbage output. The more accurate data we put in, the better usable output we'll get out. One of the other limitations is that not everybody registers their puppies, which will skew litter-sized related data. So it's not clear if the litter data is stuff we're going to be actually able to use. And these programs also do not account for relatedness of founders. Programs assume all founders are 100% unrelated, and this isn't true. We know that Crystal Sunrise, Snowflake Obsidian, and Juno are all related to Peacock, who is one of our big founders in the breed. Additional limitations are there are issues with our data. So I found that there were at least 41 dogs missing a date of birth. Some dogs were born before mothers, as you can see in the error messages I got from Retriever on the right. Some dogs had no sex listed, and sometimes the programs can't figure out what they are. And parental IDs, some were missing sire IDs, some were missing dam IDs, and it's not clear whether these were just if these are genuine founders in the de-identified forms, or if they got separated from the rest of their pedigree. Additional limitations is Retriever is supposed to work in English. However, at this point in time, it only exports into Dutch for me. So I needed to take additional time to translate and verify the data, and some of the graphs and charts were incomplete, and I needed to clean them up. PopRep data is very dense, and it takes a while to go through and verify. And very, very important thing to remember is that the output I am presenting today is all probability based. It's mathematics. It's not a substitute for real-time genetic surveillance. So after all of this, can we answer those questions I asked at the beginning? And the answer is no. We do not have the data on the whole Silken Windhound population. We only have data on the registered Silken Windhound population, with an additional handful of embarked data points for genetic COI. So how can we revise our original questions to get meaningful answers from these programs with our registered Silken Windhound data? And how we do that is we revise it. So what does pedigree completeness look like in registered Silken Windhounds? What does the registered Silken Windhound population look like? What registered Silken Windhounds are being bred? How many times are they being bred? When are they being bred? How many puppies are they producing? How many of those puppies are then selected to breed? Do we have popular parent syndrome? Can we identify overrepresented parents? What does dams parity look like over their breeding life? What do registered litters look like? What's the generation interval for registered Silken Windhounds? How does this compare to other dog breeds? What does probability-based COI in breeding look like in Silken Windhounds? Can we compare this data to Embark, which is genetic-based? What about kinship? What does kinship look like between Silken Windhound pairs? And what's important for eventual acceptance into FCI is what is the breed's effective population size? How close is it to recommended sustainable numbers? And how does the effective population size change when you look at inbreeding? So to answer these questions, we had to prep the data. Nick Cross anonymized the ISWS registry data for me. Each name was replaced with a unique ID number, included data entered up until late July of 2021. And the latest date of birth included in that data was from a dog born in December of 2020. So all of the data that you're looking at today only includes dogs born up until December of 2020. It doesn't have all of the dogs that were registered in the last few months of this year. And it also includes all of the proto-Silken Windhounds, all of the founders that went into our breed. And it's not very easy to separate these individuals from the rest of the known Silken Windhound population. The final data that Nick gave me included an ID number, a dam ID, a sire ID, a date of birth, and sex of the individual. There were 3,236 of these individuals in the database that I was given. And you can see what it looks like on the right, from the straight output I was given to what Retriever needed the input formatted as, and what PopRep needed the formatting for its input. Additional prep involved Charlie Ann Cross, shared total puppy numbers for the 2014 to 2020 numbers from AGM reports, so I could have a more total population to look at in some cases. I have age-matched Embark COI data, but we're not really going to look at that today. And James Halstead assisted in getting Retriever set up for me. So additionally, empty sire and dam IDs were corrected to 0 or unknown, which forces Retriever to accept that they are unrelated founders. I tried to clear date of birth from some individuals with errors so that I could get more complete kinship calculations without the programs complaining too much. I ran Retriever and PopRep with appropriately formatted inputs. Again, James Halstead helped me with troubleshooting. I translated and reformatted Retriever output. I adapted the Retriever output into figures and extracted figures from the PopRep automated reports. I also compiled final figures with some of the additional Embark and AGM report data. And again, like I mentioned earlier, all final data presented includes the proto-Silken Windhounds, the founders, and genetic diversity project dogs as Silken Windhounds. So our results are going to be addressed in this format, and we'll go through each of these one by one. So first off, what does pedigree completeness look like in registered Silken Windhounds? The deeper and more complete the pedigrees within a registry, the higher quality the input. More incomplete pedigrees will lead to overestimated population sizes and inaccurate inbreeding calculations. So this was a genogram. This is a genogram created by James Halstead using some of the de-identified data. And as you can see on the left, we have an example of a deep pedigree where it goes from the 0 generation up 2 generations. And on the right-hand side, we have 2 examples of a shallow generation compared to the left. They only have their parents as their ancestors. So we're looking here at average pedigree completeness, or PCI, of registered Silken Windhounds from 1982 to 2020. And this is output from PopRep. And so pedigree completeness index, or PCI, is not actually about pedigree completeness. It's about predicting how accurate inbreeding calculations may be based on how many recorded ancestors are in a pedigree across both tails. So the closer the relationship to the individual, the heavier it is weighted. This is a quality control check on our data. So it's really important that we have the accurate pedigrees that we're going to be looking at. And so what we see here is that in red, the red box on the left, that's when an average PCI of 5 generations or 6 generations is low. It means there's more pedigree gaps and that inbreeding calculations may not reflect what is actually happening. But on the right-hand side of the graph, you can also see that when the average PCI of 5 or 6 is high from 2005 on, inbreeding calculations based on pedigree are more likely to be accurate. And why are we looking at a complete 5-generation pedigree? Why is that the magic number? It's considered the standard for establishing relatedness for inbreeding calculations. And we can see already in this quality control check of our data that we do find out something important. That pre-ISWS formation, we had very low PCI for generations 5 or 6. But after ISWS was formed, we see much deeper pedigrees, which means our data is good, especially for recent years. Our next figure is looking at the depth of pedigrees, and this is output from Retriever. So we're looking at the completeness of pedigrees of ISWS registered Silken Windhounds from 1982 to 2020. And so what you can see is, again, pre-ISWS, we don't have very deep pedigrees. They're pretty shallow. They're only 1 or 2, maybe 3 generations deep. But after ISWS, we're building on those great-grandparent pedigrees. We're going and getting great-great-grandparents, great-great-great-grandparents. So by now, in the last 5 years, more than 50% of registered Silken Windhounds have a complete pedigree, meaning they have 2 parents, 4 grandparents, 8 great-grandparents, 16 great-great-grandparents, and 32 great-great-great-grandparents. And that's shown in the orange portion of the graph on the right. Single generations after 1999 may indicate that there are introductions of new genetic diversity project founders and lines. So that's what I think those little blips are on the bottom of blue and red. This figure is showing the average generation equivalent, and this is from Retriever as well. So basically what this is telling us is how deep can we go in Silken Windhound pedigrees. So pre-ISWS, the maximum number of generations you could get in a pedigree was 4. But post-ISWS, the generations get deeper and deeper and deeper, and it's a continuing trend. There's no stalling, there's no decreases, and we can get a maximum of, we can get an average generation equivalent of 8 deep. So if there's an empty year on this graph, it means that there were 0 puppies born or registered. And I've highlighted in green that, again, that this steadily increasing numbers since ISWS formation is good. It means pedigrees are getting deeper with time, even with diversity project introductions. So now that we've looked at pedigree completeness, what does the registered Silken Windhound population look like after almost 40 years? Here we have the cumulative ISWS registered Silken Windhound population from 1982 to 2020. And I've highlighted in yellow on the left where the proto-Silken Windhounds should be. And as you can see, we have a increasing slope over time that especially increases after ISWS formation in 2000, and we see the slope of the curve increases around the same time when we reached UKC acceptance. So this is great. It shows that our overall registered Silken Windhound population is increasing. And maybe it would be good to investigate what the current active population is, because this is all the dogs that are registered. We don't know which dogs are dead or which dogs are active necessarily in breeding circles, and that would be a good place to investigate. And so here, again, I've highlighted proto-Silken Windhounds on the left side of the chart for ease. This is the number of Silken Windhound puppies registered with ISWS each year from 1982 to 2020, and this is output from Retriever. So each bar is the total number of registered Silken Windhounds for that year. And again, we see that the Silken Windhound puppy registrations increase each year, and we see an increasing birth trend in registrations from after ISWS formation and also after UKC acceptance. But then we see that there's kind of a puppy birth or registration plateau occurring from 2017 to possibly 2020. And that's something that we should also be investigating, because we were on an upward trajectory, and now it seems to be stalling when you look at the year-to-year numbers. But now we're getting into the fun data, and we're going to look at what's happening in our breeding population. So first off, who's producing registered Silken Windhound puppies each year? And so this is from PopRep, and we can see that in red is the total number of registered Silken Windhound puppies born each year. And below that red line, we can see the number of unique dams that produced those puppies each year in green, and the unique number of sires in blue that contributed to those puppies. And right off the bat, we can tell that sires contribute to multiple litters in a year compared to dams. And all of this data includes founders in it. So what portion of registered Silken Windhounds produce registered puppies? So this is looking at, again, total registered Silken Windhounds born each year. And what you will see in blue these are puppies that were born in that particular year and never produced puppies. They never sired or whelped additional puppies after they matured. In red, on those same bars, you will see the portion of Silken Windhounds that contributed to future generations. And what we can tell from this data is that only a small percentage of all registered Silken Windhounds born each year are used for additional generations, and some appear to be used very young. This is breaking down the previous chart into just the male population. So if you look at males, again, blue are male puppies born in that year that never sired puppies in their life so far, and red are those that did. And we can see that there are some dogs in 2018 and 2019 that are siring puppies, and these are pretty young. And this is the same chart, but for female puppies. So these are bitches and dams. So blue is all the female bitches that never produced puppies in their lifetime, whereas red is the portion of the total number of puppies that did produce Silken Windhound puppies at some point in their life. And all of these data from the last 3 charts are from Retriever. And the takeaway from all of these is that a very small percentage of registered Silken Windhounds are being used for the future generations. And I wanted to break it down because what's happening in the overall population versus a recent time period. So I looked at the overall population from 1982 to 2020, and then I looked at a smaller time period where these animals were mature, they were bred, and likely a good number of them that were going to be bred have been bred since they're 7 to their math failing me. So they're 7 to 5 years old. And what I found is that the percentage of registered Silken Windhounds that become parents is decreasing when you look at the entire population versus a more recent population. So overall, 25% of all registered Silken Windhounds will become parents, versus in the 2014 to 2016 period, only 23.3% of registered Silken Windhounds will become parents. And this number decreases even more if you look at the unregistered puppies, the numbers that I got from Charlie Ann Cross. So if you incorporate the unregistered Silken Windhounds who cannot breed and be incorporated into our breed registry, and you combine them with the never bred Silken Windhounds, then the total population of Silken Windhounds that are becoming parents drops to 19%. And that's 1 in 5 dogs that's contributing to the next population, the next generation. And that means that this is an indicator that our effective population size is probably on the smaller side, and we are vulnerable to changes in the population. So the next set of data that we're looking at is, this is basically the same data that I just showed you from Retriever, and this is output from PopRep. And an important point is that PopRep includes founders in their numbers, whereas Retriever doesn't. So when you're looking at this table and you see birth, that's indicating the number of different sires or dams that contributed to the puppies born that year. And select means it's the number of puppies born in that year that then sired or whelped puppies later in life. The higher this number is, the easier it will be to avoid inbreeding and popular sire syndrome. So what this tells us is that PopRep trends agree with Retriever, which again is another data check for us. Ideally, in a simple system, the sire to dam ratio will be 1-to-1 and matings will be random. But we are not in a simple system. But what we can tell from the row outlined in green is that there are less overall sires used and selected per year than dams. So here it tells us that there were 348 sires that contributed to the overall Silken Windhound population and 484 dams. That is not a 1-to-1 ratio that we were aiming for. And when we look into this further, what we can do is we can look at the maximum and average family sizes of registered Silken Windhounds. So this acts as a data check, because what we want to see is we want to see no variation in family size. Family size between sires and dams should be equal. And what we can see in this table is that this is not the case. What we see in this table outlined in the blue row is that sires have larger pools of offspring compared to dams, and that sires have more selected offspring than dams. And ideally, what we want to be doing as a breed is to minimize loss of genetic variation. Family sizes should be equal. So this is an indicator that our breed is not in the best situation, possibly, moving forward. And this is, again, the same data, but from Retriever. So this, again, acts as a data check between PopRep and Retriever. So here, again, we see that sires have larger pools of offspring, and they have larger pools of selected offspring compared to dams. So we do not have equal family sizes. And this can be visualized here. This is the Retriever data visualized. So this is the average number of puppies born each year to sires and dams of those years. So in 2000, there were 10 puppies born on average to dams that year, but sires had 12 puppies born to them on average. So this is visually showing us that over the time of our breed, those last 40 years, sires have had more offspring consistently over their lifetime compared to dams. And then when we look at their maximum number of puppies, sires outproduce dams by quite a bit. So these are the maximum number of puppies born, produced by the most prolific sire and dam in that birth year. So we can see that sires are, again, producing higher maximum numbers of offspring over their lifetimes compared to dams. And now we're getting more into the what's going on within the population. So are sires producing more because they're being used later? Let's find out. This is from Retriever and is looking at the average age of parents at birth of their offspring. So for puppies born in the year 2000, the dam's average age that year was 4, and the sire's average age was 6, and that's not a bad number to have. So, but when you look overall in that 40-year time span, what we find is that the overall average age of sires when offspring are born are 3.9 years. And the overall age of dams when offspring are born is 4.17 years. And that was an unexpected finding, because my understanding is that sires have a longer reproductive shelf life compared to dams. So for the sires to have such a smaller, a younger average age compared to dams was surprising. And overall, the age a Silken Windhound becomes a parent at is 4 years. And we see a trend, unfortunately, that after ISWS was formed, that there is a drop in average parental age, and it takes a number of years for this to recover, which suggests that the dogs that became parents entered the breeding population younger rather than were used more often. And now we're going to focus a little bit more on the male population of Silken Windhounds. So when are these dogs being used? When are sires being used? So here we have from PopRep an age distribution of sires in reproduction by year of birth of their offspring. And what we can see here is that over the 40 years of our breed, that sires skew young in registered Silken Windhound population. We have a number of sires that are less than a year old when they sire a litter. And there are a lot of 1- and 2-year-olds when they sire litters. There's some older sires as well. But I think what was surprising is how young male Silken Windhounds are used over their lifetime. And from here, we're looking at which males were used each year. So this is the contribution of top 10 popular sires each year to registered litters as output from Retriever. So what this is showing you is if the stacked column does not reach 100%, then the top 10 popular sires did not sire 100% of all litters produced in that year. Unfortunately, it also means 10 or less sires a year produced all Silken Windhounds registered litters from 1982 to 2002. So the beginning of our breed history is not great for sire contribution, but it's getting better in the last 5 to 10 years in terms of diversity. And also from Retriever, we can look at who was the most popular sire each year. So we can look at how many actual sires were used each year to produce puppies. And it ranges from 1 to, again, 10 between 1982 and 2002. And after that, we get 12 sires a year, 20 sires a year, all the way up to 61 sires a year in 2017. But the one that is most important on this graph, or most in this table, the most notorious, is sire number 1373. And what this chart from PopRep is telling us is what sires had the most registered progeny offspring in the entire registered Silken Windhound population. And we can see sire number 1373 all the way on the left with 47 offspring over the entirety of his lifespan. And this chart is telling us that Silken Windhounds do have a problem with popular sires with high numbers of progeny offspring. And just going off of this data, if 1373 existed today, by FCI guidelines, it would be recommended he be removed from stud because he would have made more than 5% of the registered puppies in a 5-year period. And that would have been decreasing the diversity that you would have available in the breed. Furthermore, when we look at these popular sires, we can look at, of their registered puppies, how many of these popular sires then have their puppies selected to breed further. And this is from PopRep. And again, we're seeing a lot of the same numbers, the ID numbers from the previous slide. And 1373 had 22 of his progeny selected, which means they were bred. And that is a huge number of Silken Windhounds that could make up the available breeding pool for that generation. So this means that popular sires have a large number of offspring being selected for use in subsequent generations, which is not great for diversity. But aside from the popular sires, how many offspring do sires produce? So this chart from PopRep is looking at the number of registered progeny offspring produced by sires over their entire lifetime. And what we can see is that, again, it's reinforcing the fact that popular sires exist in Silken Windhounds. Sires produce an average of 9 registered puppies in their lifetime, but there is a subset of about a dozen dogs that have more than 30 puppies in their lifetime, which is huge compared to the sires that are only producing 1 to 4 puppies. And this is showing that of the number of selected what the number of selected registered progeny offspring per sire are. So of all those puppies that sires are producing, on average 9, what we see is that of those 9 registered puppies, these are the number of puppies that are then being selected to produce the next generation. And again, the popular sires are having more than 13 puppies selected for, decreasing diversity in the available generation that they're going to produce puppies for. And many sires are only having less than 3 puppies selected for. And this is all the male portion of the Silken Windhound population. What does this look like in the female population? So we're going to start with age of the dams. So when are dams being used? And this is from PopRep, and we're looking at the age distribution of dams in reproduction by year of birth of their offspring. And what we're seeing here mirrors what we see in the male Silken Windhound population. What we're seeing is that these dams are skewing young in the registered Silken Windhound population. We have a lot of dams that are being used and producing puppies under 1 year of age, at 1 year of age, at 2 years of age. And we as a breed need to be health conscious, and some of these dogs may not be completely mature or health tested when they are producing litters of puppies, and this is a concern. And we can also look at how often are dams being used. And so is this contributing to why we have a sex ratio imbalance between sires and dams contributing to litters? And what we see here is that most dams, so this is the distribution of dams by parity. So from PopRep. So how many dams have only had 1 litter, 2 litter, 3 litters? There is a single dam that's produced 8 litters. There's a single dam that's produced 7 litters. There's a single dam that's produced 6 litters. But most dams are only going to produce 1 to 2. They are not going to have the pool of offspring available to them for retaining genetic diversity that the sires have available to them, because the sires are being bred more and repeat used more than the dams in our population. So which dams are being used? And we see a similar skewing, but not to the same extreme that we see in male Silken Windhounds, where dams with the most registered progeny offspring are seen here. And the highest number of offspring produced was by dam with the ID code 1453, and she produced 33 offspring over the course of her lifetime. And we had other dogs in the sires that were 20, 30 offspring. But here, even the most prolific dams at the right-hand side of this chart, they've only produced 15 offspring over the course of their lifetime. That could be 2 litters. That could be 1 litter, if my memory serves correctly, for one very large litter Silkens have had. And we can break this down into which of the dams' registered offspring are then selected for future generations. And we again see that 1453 is most selected for. Almost half of her progeny were selected and bred. But other dams, even the most popular ones only have 6 or 5 offspring selected. It's not nearly to the same extreme, again, that sires have offspring selected for future populations. And again, if we're looking at dams and what they're able to produce, we're looking here at the overall number of registered progeny offspring produced by dams over their lifetime. And the average is dams will produce 7 registered puppies in their lifetime. And that means that they're producing 2 less registered puppies compared to sires. Are they actually producing less puppies? Or are their puppies just not being registered? Like, this is a problem with the data that we have at our disposal. We don't know if it's a dam problem or if it's a registration problem. But this shows that on the right-hand side of the chart that we have a popular bitch problem, same as popular sire problem, and that the majority of dams are not producing very many puppies over their lifetime. Well, we don't know if they're producing very many puppies. We know that their puppies are not being registered. And so here we're now looking at, of those puppies that are produced, so those 7 puppies over a dam's lifetime, how many are going to be selected? And the selection numbers are pretty close to sires, but it's skewed because we have the very popular dams where many of their offspring are being selected, but a very large number of dams, only 1 or 2 offspring are being selected for them. So scientists at Embark conferences and other conferences have been trying to emphasize that the best of the best of the best of the best should not be your only option for breeding. There should be siblings that are being bred. And we don't see that happening here. We see that there's a lot of single puppies being chosen to breed from these dams. And now that I've given you some background on sires and dams, what data can we get for registered litters? And unfortunately, the litter data that we have is not great. So this is registered litter size of Silken Windhounds, and I chose a time period from 2015 to 2019. So this is recent. It reflects recent breeding practices, I hope. And we have a lot of singletons registered, some litters that are 2 or 3 being registered. And I want to use this data to answer questions, but we can't, because we don't know how this actually reflects on actual litter sizes. So are most Silken Windhounds having only 1 to 3 puppies when breeds of comparable size are having 5+ puppies in a litter? Is high COI causing a low number of puppies? Is this an X-linked fertility issue? We can't address any of this because the data isn't high quality enough and doesn't address these issues either. And there's a huge difference here between multiple singleton litters being registered in the breed versus a single puppy being registered from a litter of 7. And we don't know which of those this is. So unfortunately, this is the only litter data that we have that are available, which is which ones are actually getting registered. But what we can look at with some confidence is generation intervals in Silken Windhounds. So what does generation interval length look like, and how does this compare to other dog breeds? So generation intervals, you look at the sire and the dam, and you measure in years the time it takes for the sire and the dam to have both sons and daughters. So there are 4 paths that you measure for generation intervals. And this is a very important data check. So a long generation interval means you have greater retained genetic diversity over time. whereas a short generation interval means a faster loss of genetic diversity over time. So again, the 4 paths are sire to son, sire to daughter, mother to son, mother to daughter. And here we're looking at PopRep data. And this is a really big table, but I wanted you to see that PopRep is doing the 4 paths that I mentioned on the previous slide. And it's also counting the number of dogs that were used in each of these. So in the early years before ISWS formation, there weren't a lot of dogs to use. So the numbers aren't a great, they're not a great population in terms of having high confidence in them. But in the last 10 years, there was more dogs, there's more confidence in this. And I've highlighted in blue the column that details the generation interval for male Silken Windhounds over the last 40 years, including the final average over those 40 years. And what you can see is that the generation time goes up to almost 7 years, which is great. And then at ISWS formation, it drops to 2.5 years. And it slowly ramps back up, but we have an issue where the overall male generation interval is 4 years. And in the female Silken Windhounds, we see the same thing. Generation interval ramps up, and then it crashes around ISWS formation, and then slowly ramps up again. But the overall female generation interval is 4.3 years. And if you look at the average between male and female generation intervals, the overall average is 4.1 years. And that's kind of short for a dog breed. There are other dog breeds that generation intervals range anywhere from 3 years in miniature bull terriers to 5 years in bearded collie. There are I believe a Swedish paper looked at Swedish dogs, a hound and a Spitz, where they had 5.8 and 5.7 generation intervals. And that's great because that means that they're retaining a lot of generation. They're retaining a lot of genetic data between generations. So if you have a 2 generation interval followed by a 2 generation interval followed by a 2 generation interval, you've done so much recombination between the genetics of those dogs over 3-4 generations that you could have in just one pairing. So that one pairing will retain more information over the 6-8 year generation interval compared to the short 2 year generation interval that's got 4 generations. So you're creating depth, which is good for calculations with short generation intervals, but you're losing possible genetic diversity by having a short generation interval. And lastly, well, not lastly, but almost last, we're going to look at coefficient of inbreeding and what does probability-based pedigree COI inbreeding look like in Silken Windhounds? And what does kinship look like? What does it look like compared to our embark data? So we need some definitions before we go forward. So kinship coefficients is also the same as coefficient of ancestry, co-ancestry. It's also the same thing as an additive genetic relationship. And it's basically the probability that a random allele from one individual, I, is identical by descent with one from another individual, J. It's based on expected but not realized genome sharing. So this is all math-based. This is statistics. We're trying to figure out what the likelihood of these 2 alleles segregating together into one individual. And kinship is always done in terms of pairs. And the coefficient of inbreeding, or what we know as COI, is the probability of 2 alleles at a focus are identical by descent from a common ancestor. It's based on expected but not realized genome sharing. Again, similar to kinship. But what COI really is, it's equal to the kinship coefficient between an individual's parents. And just for some examples, full siblings would have a kinship of 0.25, but half siblings would have a coefficient of 0.125. And here we are looking at output from Retriever, and this is the comparison of average coefficient of inbreeding and average kinship, excluding self, by year of birth. So how Retriever does this is the coefficient of inbreeding and kinship coefficient is calculated with all other animals born in that year. And what the takeaway from this is actually encouraging on paper, that there is a stable COI and kinship level after the formation of ISWS, and this may or may not indicate that the genetic diversity projects are working on paper to introduce diversity into the Silken Windhound breed. However, this is probability-based estimation, and it's not actual genetics-based. And what this also tells you is that Silken Windhounds, on average, are as related as half siblings, but less related than full siblings. So if you took two dogs and you sat them next to each other, you could assume genetically, based on this mathematical probability, that those two dogs are as related as half siblings. And there's another important part of this graph, which is there is a spike around 1994 of inbreeding. It goes up to almost 35%. And this we will look at later, but this is a point in the breed history where the effective population size dropped to almost only 4 individuals. And because there were only 4 individuals, being the equivalent of only 4 individuals actively being bred, that is why there is the spike in kinship, because they were more related, and also the spike in inbreeding because the parents that were bred were related. They had kinship. Now we're going into data from PopRep, and I'm showing you this even though it's basically the same thing as the previous chart, because this acts as a data control. This is the average additive genetic relationship, which I mentioned earlier is the same thing as kinship, and inbreeding coefficients by year of birth. So this graph should look the same as the one I just showed you if it's using the same data. However, it is a little different, and what you can see is that the kinship, the additive genetic relationship, is lower in this population and doesn't have quite the extreme spikes that the Retriever data has. And this is because PopRep calculates additive genetic relationship kinship slightly differently. Here, PopRep is taking the average kinship from a random sampling of individuals born in the year being calculated. So this is useful for very, very large populations, but less so for our newer breed, which is smaller. But overall, PopRep and Retriever data agree on the coefficient of inbreeding, and the trends that we see in PopRep in relation to kinship agrees with the Retriever data. And what we are looking at here from PopRep is it's comparing the average coefficient of inbreeding. So you should recognize the spikes that we see on the left. That's almost 30% and 35% in early generations when there was lower effective population size. And it's comparing the coefficient of inbreeding to the number of inbred Silken Windhounds in the population. And what we can tell from this is that almost all Silken Windhounds born after the ISWS formation are considered by PopRep to be inbred. So the coefficient of inbreeding for registered Silken Windhounds is higher than that of half siblings, but below full siblings. but it's stable at this point in time on paper when you look at pedigrees. And this data from PopRep is showing the rate of inbreeding and the increase in additive genetic relationships by year of birth. So what we're looking at here, PopRep could have used colors, but the bolder line is the change in kinships or the additive genetic relationship by year of birth. And what it's telling us is that our population of silkens is not necessarily becoming more related, and this may be due to the introduction of genetic diversity projects, but they're not unrelated enough to create large valleys like we see in the inbreeding, the change in inbreeding line. So the change in inbreeding we see goes up very high, it goes very low, and part of why it does this before the formation of ISWS is because it's influenced by the very small effective population size. So that's why we see such large increases. If there's only 4 effective dogs being bred, then the next generation is going to be more related and it's going to have higher inbreeding. And then we see the change in inbreeding, it goes down, presumably because there's an increase of, or an introduction of presumably unrelated founders. So here, what I've done is I've taken data from PopRep, and what PopRep will do is it will look at the coefficient of inbreeding for the entire population of registered Silken Windhounds, and it will break it down by both year and it will stratify the population. So it breaks it down into dogs that have a COI between 0 and 5%, 6 and 10%, 11 and 15%, 16 and 20%, 21 and 25%, 26 and 30%, 31 and 35%, 36 and 40%, and 41 to 45%. And what I did is I took the totals for the columns. So this is all the Silken Windhounds over the last 40 or so years, and they were broken down into these coefficient of inbreeding layers. And what we see is that the majority of Silken Windhounds, according to PopRep, have a COI of 16 to 20%, which is not that bad on paper. This is not terrible compared to what some other breeds have reported. But again, this is probability based. It does not actually reflect on the genetics of the registered Silken Windhound population. So what does that look like? So here I've taken a graph from Embark, one of my dog's Embark pages, and we can compare the paper pedigree COI on the left from PopRep of the entire Silken Windhound population, and we can compare it to the Embark population of Silken Windhounds. And what we can see is that the actual genetic-based COI of Silken Windhounds, which is based on runs of homozygosity from SNP data, is at least, there's a shift by 10% compared to the pedigree-based COI. So the higher, most of the Silken Windhounds in pedigree COI we see in the 16 to 20% range. But here, when we look at genetic-based COI, we see most of them are between 25 and 30% genetic COI. So what that means is we have lost diversity, possibly due to the skewed sex ratio between sires and dams in litter production and selection. The overuse of sires compared to dams, where they're used 3 or 4 or 5 times, and dams are only used 1 or 2 times. The younger generation interval, so the shorter generation interval may be contributing to loss of genetic diversity. It's hard to say what is responsible for the shift we see from the probability-based COI to the actual genetic-based COI. And now that we've gotten through everything else, we can address effective population size. So what is it? How close is it to the recommended sustainable numbers? And how does the effective population size change when you look at inbreeding? So this is pulled straight from Wikipedia because they can explain it a little bit better than I can. But the effective population size is the number of individuals that an idealized population would need to have in order for some specified quantity of interest to be the same in the idealized population as in the real population. Unfortunately, idealized populations are based on unrealistic but convenient simplifications like random mating, simultaneous birth of each new generation, constant population size, and equal number of children and parent. So we've already addressed this in previous slides where we know we haven't had a constant population size, and that's been varying quite a bit over the last 40 years. We know we don't have random mating because we see that males are contributing to litters more than females, and equal numbers of children per parent. We already know that we do not have that in our population because the sires are producing more offspring than dams. So what PopRep does, and I'm choosing PopRep to illustrate the effective population size because PopRep is more thorough than Retriever in this regard. So what PopRep does is it has 6 different methods for determining effective population size. And what figure A on the left shows you is how they are doing it. So it's showing you what generations it is looking at for each of these methods and who they are looking at for figuring out the effective population size. So if they're looking at just the offspring, if they're looking at the future, if they're looking at the past, if they're looking at the parents. And what table B on the right shows is it explains each of these methods in more depth. So LN focuses only on animals born in generation T. Delta FP focuses on animals and their parents born in generation T. Delta FG focuses on animals born in T and T-1. Co-ancestry focuses on animals born in generation T+1 and T, and ECG focuses on animals with their complete ancestors born in generation T, whereas the census looks just at parents of animals born in generation T. So now that we have these 6 possible methods, PopRep then goes and has a decision cascade with side conditions that looks at both completeness in years for the methods in question and the stability of the population over those years. And if there's a difference, and if this population is complete over those years and stable, then we get the yes, okay check. And if it's not, then we get a no and get told to move to the next method for determining effective population size. And so we work our way down from co-ancestry all the way down to census, because census, while great for getting effective population size, is not looking at rates of inbreeding and looking at how many possible distinct individuals you have within the population. So that's why it's at the bottom of the cascade, the decision cascade. So when we do all of these methods, look at all the completeness, stability, side conditions, what we determine is that our best method for determining effective population size is the delta FP method, which, if you look over these years, in 2015 we had a effective population size of 55. In 2016, we had an effective population size of 42. In 2017, we had an effective population size of 38. In 2018, 36. 2019, 36. And even though we only had population-wise half of the usual number of registered puppies for 2020, we had an overall increase in effective population size, possibly from diversity of dams and sires used. And another important data quality control check is that if you compare the two methods that I asterisked with a little purple star, delta FG and co-ancestry, if breedings were completely random and mimicking an ideal population, delta FG and co-ancestry would have had similar values, but they don't. They are wildly different, which means that we are not preserving some of the diversity that is hidden away in pockets of our population, and we may be breeding away from it. And this is just a visualization of those various effective population size methods over the last 40 years in our breed. And the one that you want to be looking for is the delta FP, which is green. And unfortunately, when we look at this particular graph, we see that there is a bold line at 200, and 200 is the preferred effective population size for sustainable populations. The next bold line under that marks the 50 minimum individuals. So it's the minimum size for a sustainable population. And this is the size that FCI would like to see before acceptance. Unfortunately, our method that determines our effective population size only breaches the 50 minimum line once in 2015, and the rest of the time it's well below that line. There are other methods that do indeed go higher than 50 and higher than 200, but in the previous slides I outlined why those numbers do not reflect accurately our population. In particular, the purple line on this graph, the census effective population size, is skewed due to family size and inbreeding within our population. And that is all of the raw data that I have to present. So the final thoughts and concerns I have from this investigation is that we do have accurate pedigrees and that they are very important for accurate calculation and data analysis in terms of they are at least 5 generations deep. And I think that this emphasizes how important it is to have continually accurate pedigrees moving forward. Like I already said, recent breed population pedigrees are deep enough for coefficient of inbreeding and effective population size calculations. Our population of Silken Windhounds has increased over time, and we see surges after availability and promotion to a wider audience, specifically with ISWS formation and UKC acceptance. So this is a good thing. When there is a wider audience available to the breed, we have a larger effective population size, and our breed overall can be more stable genetically because there's more people with them. It's less tiny pockets all over. We also saw that sires are reused more often than dams, leading to family size skewed towards sires, and an unequal family size equals a lower effective population size and increased loss of genetic diversity. There's also a subset of the population that's overused both in sires and dams, and their offspring is overrepresented in the selection of future generations' parents. This, combined with lower generation intervals, may be contributing to the genetic loss that we're seeing of genetic diversity with the EMBARK data. We see sires and dams are being used before age 2, and this lowers the breed's generation interval, resulting in faster loss of genetic diversity. But positively, we're seeing that there are population surges associated with, ISWS formation and UKC acceptance. But unfortunately, this is in part from younger than average individuals entering the gene pool earlier. So this lowers the generation interval and increases genetic diversity loss. So what would have a great alternative to what actually happened would have been to encourage the use of dams and sires that were already in the breeding pool and engage with them more rather than initiating younger individuals into the gene pool sooner. Our effective population size is too low for FCI acceptance at this point in time. And because it's a low effective population size, we're very vulnerable to popular sire syndrome. But how can we, as owners and breeders of Silken Windhounds, help move the breed in a positive direction with all of this quantitative data? We need to try and equalize family sizes between dams and sires. So either dams need to be reused more or diversify through sires. Don't use a sire 3 or 4 or 5 or 6 times. We need equal numbers of unique sires and dams used in breedings. We need less repeat litters, and we need a delay in breeding sires and dams to increase our generation interval. And part of this, we have generation diversity projects, and they're time-consuming and expensive. So why would we increase the loss of this added diversity with unequal family sizes and short generation intervals? Like, we have these protocols in place, and we should be taking advantage of this. We already know that if we have longer generation intervals, we'll have more genetic diversity retained from these projects. Are there current limitations to breeders using new males or females in programs rather than repeating, or what FCI calls matador breeding? Is it geographically based? Is it knowledge based? Is it availability of health tested Silken Windhounds? Is it habit or old formation? This would be good things for the club to investigate. For dams and sires contributing to short generation intervals, are they being properly health tested or reaching adult maturity before breeding? I'm concerned about the animals that were under 1 year of age producing litters. I'm concerned about the 1-year-old dogs that were producing litters. I'm concerned even about the 2-year-olds because those 2-year-olds are shortening our generation interval. Can the club promote more careful breeding? FCI recommends that the top 50% of the breed be used, and this mirrors what EMBARK scientists spoke about at the health conference in 2021, that the best of the best of the best of the best should not be the only ones used. So why are only 25%, 20% of silkens being used, and in disproportionately skewed in the sires in particular? We need more silkens and therefore more breeders. What will ISWS as a club be doing to engage new owners and breeders? If we're going for AKC acceptance, there's going to be a surge. There was a surge when ISWS was formed. There was a population surge when UKC acceptance happened. We have the data that will predict the AKC surge. So how can we set ourselves up for success with future breeders? Because the AKC recognition will probably result in another expansion phase. And so for my future directions, what I would like to look at more with data is to continue to monitor the population at hand and refine the input and outputs to evaluate specific populations like proto Silken Windhounds versus founders versus the actual Silken Windhounds, or even diversity projects, or even fine tune it to specific time periods. What did post ISWS look like immediately compared to today? Use the data that we have to correct issues in the registry, whether it's date of birth related, sex, or etc. I'd like to incorporate embark data and health data, but this is difficult with the anonymized, de-identified data from the registry. And collecting embark data is difficult because not everybody gives the same amount of data. I'd like to expand the data analysis using R, and you can see an example of what we're capable of on the right, which is, I call the unicorn tail. But basically, this figure, which my husband James Halstead helped me make, is an example of the max depth of generations that you have in a given year of dogs that are born. So you can see in 1982, the max depth of those dogs is only 1 generation, 2 generations. But as we go forward past ISWS formation, past UKC acceptance, up to the year 2020, we see that there are dogs that have a maximum depth of 16 generations. And part of that might be due to short generation intervals, but like we have depth there. We have data there. I think it would be great to develop programs to encourage evidence-based and health-conscious breeding of Silken Windhounds to lengthen generation interval and equalize family size by discouraging, eliminating repeat litters, encouraging diverse sire usage, limit popular sire usage, allow Silken Windhounds to mature before breeding. Our increased COI and short generation interval put us at risk for health issues. And I think that increased health testing is vital now before an AKC acceptance happens and the associated population surge with it. So if there's anything going on in our breed, it's best to sort it out now before AKC acceptance. And maybe, who knows, it might be a good idea to develop some sort of centralized storage of older male genetic material, because that gives us easy access to genetic diversity. It gives us easy, long generation intervals if we can do things like that. And I'd like to end with acknowledgements. Thank you, Nick Cross, for anonymizing and exporting the registry, the ISWS registry for me. Thank you, Charlie Ann Cross, for providing the additional litter data from the 8 previous AGM reports. The ISWS BoD for letting me do this project, breeders that register their puppies, and my husband, James Halstead, for sitting through this presentation numerous times. And you can see some of the references that were used for this presentation here. Thank you.